Now I'll be talking about the projectile fired at an angle with horizontal. Now we have a projectile which is at an angle theta with the horizontal and it is fired with a velocity of u. Then we'll derive an expression for this. So the first thing is that it is fired with an initial velocity between angle theta with the horizontal. So we can resolve the initial velocity into two components. The horizontal component ux will be u cos theta along OX, while the vertical component of the initial velocity will be uy u sin theta along OY. So this horizontal component of the initial velocity will propagate the projectile in the horizontal direction, while the vertical component uy is equal to u sin theta will propagate the projectile in the upward direction. Now motion along horizontal. For this, we have the acceleration ax is 0 because it is at constant velocity, ignoring the air resistance. So, from the second equation of motion, s is equal to ut plus half v square. S is here it as x at point p. We'll consider point p, which is at time t. So s becomes x and u becomes ux. Time is t half at square. So a is ax here and time is t square. Again x is equal to ux is u cos theta t plus half at square. Ax is 0. So this becomes x is equal to u cos theta t. From this we can get t is equal to x upon u cos theta. This becomes first equation. Now motion along vertical. For this, acceleration in vertical direction will be minus g because the projectile is thrown upward. So acceleration will be acting against it. And from second equation of motion, I write directly y is equal to uy, here it is uy t plus half ay t square. So y is equal to uy is u sin theta t plus half ay is minus g t square. Now this becomes y is equal to u sin theta t plus minus half gt square. So this is the equation along motion along vertical. Next topic is equation of trajectory. We have seen that y comes out to be u sin theta t minus half gt square. Putting the value of t from the first equation as u sin theta t is x upon u cos theta minus half g x upon u cos theta whole square. This comes out to be, u get cancelled by u and x tan theta minus u g u cos theta u square cos square theta, and we'll write it separately x square. This is the equation of the parabola fired at angle with horizontal. This is the equation of the trajectory. From this equation, it is clear that it follows a parabolic one because x square is clear. Y is equal to x square, which is the equation of parabola. So it follows a parabolic. The trajectory is a parabolic part. You can see it in the figure. Next topic is time of flight. The time for which the projectile is suspended in the air, or the time the projectile takes from O point to Q, is called the time of flight. It is represented by capital T. Now you can see that the projectile trajectory from O to Q is symmetrical. To reach from O to A and A to Q, it will take the same time. Supposingly T by 2 it takes to reach from O to A. So it will take the same time, A to Q. t by 2 to reach A to Q. Now we'll consider its motion along O to A. At the highest point, the final velocity will become 0 along y-axis, and the initial velocity is uy. We know it's u sine theta, and acceleration along ay when it's going O to A is minus g. So from the first equation of motion, we know v is equal to u plus at. So vy is equal to uy plus ayt. Vy is 0, uy is u sine theta, ay is acceleration is minus g, and t is t by 2, because from reaching from O to A it takes the half time. So the expression of this will be minus u sine theta minus g upon t2. Solving it further, we'll get t is equal to 2u sine theta upon g. So this is the expression of time of flight of a projectile at an angle with horizontal, at an angle theta with the horizontal. Next topic is maximum height attained by the projectile. The projectile will attain its maximum height at point A. It will take time t by 2 to reach there, and from the second equation again, y is equal to, we'll consider the motion along the y-axis. Y is equal to uy t plus half ay t square. Now uy is what? U sine theta. T is t by 2 plus half ay is minus g, because it is from O to A, opposite to the influence of gravity, and t is again t by 2 whole square. Now we'll put the value of t by 2 from the previous equation of time of flight. So t comes out to be 2u sine theta upon 2g, because there is a 2 here, so it will cancel out, plus minus 1 by 2 g. T is again 2u sine theta upon 2 square, so it will cancel out again. Y also becomes h, maximum height. This becomes u square sine square theta upon g minus 1 upon 2 u square sine square theta. Taking the LCM, this becomes 2g as LCM. This becomes 2u square sine square theta minus u square sine square theta. There is a g here because it is square, so there will be a g left here, so it becomes this. Now h is what? Solving this, u square sine square theta upon 2g. This is the expression for maximum height of projectile. Now horizontal range, it is the maximum displacement moved by the projectile in the horizontal direction. So for the expression of horizontal range, r will be speed into time, distance is equal to speed into time. So r is equal to speed, will take this velocity as initial velocity ux, that is the velocity along horizontal, ux into t. Ux is u cos theta and time will be t. So this becomes u cos theta, time is, you know, the expression is 2 sine theta, 2u sine theta upon g. So this comes out to be 2u square sine theta cos theta upon g. We know 2 sine theta cos theta is sine 2 theta, so we can write it as u square sine 2 theta. This is the expression for horizontal range of a projectile. Angle of projectile for maximum range, we know the expression for maximum range, that is r is equal to u square sine theta u square sine 2 theta upon g. So sine 2 theta, value of sine theta is maximum, which is 1, and sine One is sine 90. Sine 90. So 2 theta is 90, theta is 45. So for maximum range, you have to throw the projectile at an angle of 45 dt. Again, the maximum range will be r will be u square sine, this will become 1 u square upon g. This will be the maximum range, r max.